Hi, I'm David with EV World News. We talk about electric vehicles, green energy, and the stock markets. And today I have a special guest, the CEO of Tellus Power, Mike Calise. Tellus Power is a company focused on high power EV charging, vehicle to grid systems, and smarter distributed energy platforms. Mike has spent years in EV infrastructure, including leadership roles at Tritium, Blink Charging, and Schneider Electric. He's one of the rare executives who has seen this market from the charger hardware side, the network side, utility side, and the capital market side. That's pretty impressive. So we're really happy to have you here today. Welcome to our show, Mike.
Thank you, guys. I appreciate it, David and the team. Really delighted to be here and excited for our talk today.
No, that's interesting. Networking, utility, and capital markets. So I'm always interested in the capital market side of thing, but I don't even think I actually have any questions on the topic.
Oh, glad to glad to talk about those. Actually, I'm pretty ingrained in the capital markets. I've taken a couple of companies public. Maybe there's a third ringing here. We'll see. But certainly been an investor and a clean tech guy for quite a while. So be glad to talk about my investments, but we'll keep that off to the side.
Yeah, that's great. That's great. All right. So you've led in charging infrastructure at Blink, Tritium, and Schneider Electric, and now Tellus. So tell me in the last 10 years, what do you understand now that you didn't understand back then? Tell us what kind of things you've seen.
Yeah, great question. I would say like nothing and everything. Back in the day, I've been in it for 15 years, but let's say even past a decade ago, EV charging was so new that it was so nascent that the first steps were, hey, we have some level 2 technology, low-end charging, medium low-end charging. Let's deploy that where it makes sense. We could deploy it based on a local mayor's community center, civic center. We could put these in areas where people may shop. We even put them in gas stations of all places. So, those deployments dotting the world with the first delivery of power to the public was absolutely important as a first step. And then we always spoke about home charging. Home charging's everything. You could leave your house with a full tank every day and get whatever miles you could get from that. So those I like to call the charging 1.0 days back in the day. And yet, even today, fast forward to 2026, there's still a contingent of people who are saying, I'll never go to an EV until I get 400 miles of guaranteed range and I could charge up in 5 minutes because that's what I do at my gas pump. So in many ways, everything has changed, and yet nothing has changed for a certain cross-section of the industry. In this charging 2.0 version, which I call it, was probably about 7 to 10 years ago, we at least started to become interested in DC fast charging as corridor charging. The importance, well, if I can't get cross-country, I don't want to buy an EV. Well, who's going cross-country every day? I mean, I don't know, but it is important from city to city. So if you want to go to grandma's house from LA to San Francisco, or you have a business meeting from New York to DC, you better be able to charge halfway and get there with no stress. And I would say that we learned a lot about coming from this sort of AC mentality, that will be fine for single family homeowners, to putting these charging stations where they are supposed to be delivered. The problem was the maybe maximum at that time was 50 kilowatt output. So if you went halfway between LA and San Francisco, that still took you an hour and a half to charge. Who wants to really wait that long? Now, the early adopter said, I'm fine, I'll take a long rest. But really now we're at charging 3.0. And that's what we've learned over from 2 to 3. And so you can quote me on that one for sure. Now it's all about maybe a 10 to 30 minute charge. I could add 200 miles to my vehicle, providing it's the proper vehicle, in about 12 minutes today. we do have very fast chargers out there. And does the battery accept all this fast charge at the same time? No, we can talk about that. However, I could still get in and out in effectively the time it takes to do a bio break, maybe get a snack, a cup of coffee, and frankly, text my kids. And there it is. I'm off. I've got another 200, 250 miles added to the tank per se. So now you go to 3.0, it's how do you manage the grid? How do you manage deploying these very fast depots without the challenges of utility demand fees, without the challenges of, say, an inordinate amount of load that can't be managed with the grid. So we're, certainly Tellus Power is a leader in being able to offer vehicle to grid solutions. And when you incorporate that into stationary storage and integrated battery with those fast chargers, now you really have a massive step change moving forward.
We were talking yesterday about some of the things BYD is doing, and they've got some incredibly fast charging batteries. They've got some incredibly large, gigawatt, 1.36 gigawatt. I mean, not gigawatt, megawatt. Oh my God, gigawatt charging.
Meg, that's fine. Oh, that will be.
We're charging on cruise ships.
What's a factor of 10 amongst friends? Or
sorry, megawatt hours chargers, and it's so easy to say the wrong one. But anyways, it's kind of just shocking that all of these technologies exist, but like you're saying, they don't all necessarily connect together. You have like 3 or 4 parts that have to all exist at the same location on the same day to make that happen at the most optimum, situation. But it's fascinating to see some of these
and
changes.
It's Mike, I appreciate your background. So I go back to about 2010 too, but from the utility standpoint, and I always like to say we were waiting for the roller coaster to start for a long time. Where 2020, this is going to take off. It's going to go forward. And wait. 2015, this is the moment. This is when wait. And now we're finally there. I say we're finally on that curve. Like the roller coaster is flying. We're learning. And to your points earlier, what we talk about a lot on this show is just our assumptions about you have to be able to charge. You have to have a full tank every morning. How are people going to? And it's gonna want to charge. It's been so fun to watch that evolve from the human aspect of like, it's new. We don't know how people are going to do this and what it looks like. And I think a lot of those assumptions we had going into it way back when of this is the worst case, it's going to just slam the grid all the time. We're finding, I don't know. It's not as bad as we thought. People don't plug in every day at 5 o'clock and charge from 0 to 100% and all of these things. It's been a really fun ride, to see a lot of that.
It was an old story. You probably heard about it as a grid guy that when we went from, gas-fired oven ranges to electric ranges, the peak around Thanksgiving when everybody's cooking their turkey, we'll absolutely take down all the transformers. We'll take down the grid. The grid is incapable of handling that. It never happened, And when you speak to the grid operators, you speak with the utilities. The amount of charging, even if we maxed out the amount of EV load at all times, it's still relatively small, under 20% total grid capacity. So I've always said the EVs are a forcing function to make the grid smarter. It's still an antiquated grid. It was designed for low wind speeds. It was designed for very long transmissions of a centralized power generation into where people needed it. And, right now the grid is getting smarter and smarter as we add more assets to the grid, as we add more load to the grid. Let's speak about data centers and other. And then relative to the technology adoption life cycle, it's always classically takes a lot longer than people anticipate for a new disruptive innovation, such as EV versus petroleum-based ICE. It takes a lot longer, but once it does then it takes way shorter than you think for it to completely convert with the new technology. And, with BYD is a great application. That is a tip of the iceberg, what we're seeing, what we see globally in China, what we see globally in the US, Europe, India, South America. We are absolutely moving. Look at Norway. They've done a great job. Small country, but very cold climate. Done a great job with policy to get it completely shifted where they're no longer responsible. That's a petroleum-based economy, no longer responsible. So that's a tip of the iceberg. China's very high technology and high scale, tip of the iceberg. What Tesla's doing, phenomenal, global in the shift to autonomy. We're absolutely seeing this take off. And now the exponential growth curve of autonomous vehicle is really an incredibly big load at the edge that we're seeing.
Air conditioning enters the chat.
Yeah,
absolutely.
Yeah. Mike, tell them about how Herzog about how coal and air conditioning worked together.
Yeah, I mean that was the last from the utility standpoint. That was the last big boom we had was air conditioning, and that really changed the grid and what it was. And our response 40, 50 years ago was coal. It made sense at the time. We weren't as concerned about the environmental impacts. It's cheap, easy to deploy. Very reliable, very robust in all conditions. So we responded to it. And from utility grid planning, we were expecting that from EVs. And that's another one on this show. We're very, kind of don't keep those EVs out of the data center discussion because they're two separate things. What's challenging the grid today is data centers, 100%. That's what's straining the grid, the headlines, and then ... and EVs are a concern. It's like, no. Someday, yes, like, if everybody gets an EV, the grid has to evolve. The grid has to change. We need to incorporate everything in there. But the reality of it is it's not going to happen for a long time. We're entering into it. And what's beautiful about it is companies like yours are having the forethought out there of, let's do it right. Like this is a blank slate. Let's take all the lessons we've learned and let's integrate brains behind this and say, we can manage this. We can think about it a little bit differently. And if we do it from square one, we don't have to double coal production. We don't have to do all these things. We don't
absolutely
have to have the same boom that we had with air conditioning 40, 50 years ago. We've learned some lessons, and I think we can do it quite a bit better.
But didn't we kind of brute force that fix? Whereas now we're trying to come up with smarter solutions.
Yep.
As opposed to just
that was a very different time. Shoot, is probably right around when the EPA was being formed. So let's drop coal. Let's drop coal everywhere. It's quick, it's fast, and we rode that for a long time. And now we're changing a little bit.
All right. So next question. A lot of people still talk about charging as if it's just a hardware deployment game. Where do you think the market misunderstands the real bottlenecks?
Yeah, great question. So in many ways, it's still a hardware deployment game because as you're seeing this, what was maybe workplace home charging on the level 2 and corridor charging, which got you from city to city. In many ways, there's still this massive requirement, what we call inner loop, where people live and thrive and work and play, where you kind of hang out. And in big cities, that could be in high-rise condominiums, it could be in apartment buildings and high-density populations. So as you bring this hardware closer to people where they could use the hardware if they don't have access to a single-family home charger at night, then it is about that deployment. However, the real bottlenecks aren't about hardware. The real bottlenecks come in the form of what we're seeing today, where many of our customers, we're not actually involved in government grants per se, because we're a capitalist company, a manufacturer, a global company, and policy changes throughout, tariff on, tariff off, multiple administrations, different views. I could share a lot of real good stories about prior administrations before this one and the unintended consequences. But when you bring that together now, a lot of what we're seeing is a gap in capitalizing these deployments. So it takes a lot of money to capitalize these deployments. And many of them went for the state grants, the local grants, and the federal grants in the form of NEVI. And absolutely, if you're that type of charge point operator, why wouldn't you take advantage? Because the cost of capital just got reduced by 50 or 80%. So you absolutely chase those grants if you're a charge point operator that is deploying. However, what people don't know is the today's bottleneck is how do you bridge the capital requirement from what is a government grant? The government any government doesn't give you 100% up front. I actually tried that in the past, and there was fraud. It was riddled with fraud. And so, human nature is pathetic. However, now, so they give you a little bit. You get the low cost of capital. You drive, you look at where utilization is higher. You've got good software to plan that out. You're within the inner loop. You're doing a little bit what Tesla's been able to do, and you're able to compete. But what the bottleneck is the amount of time it takes before that deployment gets just shovel ready or even permit ready, to where you have to load up your supply chain, make sure you have interconnect commitment from the utility. That's not always overnight, as we know. It could be 6 months, it could be 2 years. With the LA Olympics coming, there's like a moratorium. Like we can't grow that quickly. So you have to deal with interconnect. So where you start to manage that is, how do I bridge the capital that's required from the first time I receive some part of the grant, this is speaking on behalf of the industry, on behalf of our customers, to when I could really put that in the ground, to where I start to make money, that thing called making profitable business from this energy exchange. And that's a pretty long cycle. You still have to, these customers of ours, because cost of capital, no matter what, is reduced. But at Tellus Power, we're somewhat shielded from the ups and downs. Look, we're not completely shielded, because customers' cash flow could be delayed. And now there's new instruments and new facilities that allow that to be built out, the infrastructure debt instruments, which are very favorable now to these types of customers, so that they could bridge that build out. But regardless of who you're speaking with right now, the largest deployers of, say, charging depots in the fleet or public charging depots, it definitely takes a lot of capital.
Yeah, there's no question. I've noticed just last year was the first year any of the charge point operators, at least in public documents, showed they were starting to make some money.
Yeah,
and
I mean, there's an old adage. That's not an old adage. It's work that I'd done with Blink in the early days, where we knew exactly when we were going to break even on the asset. We knew exactly what our utility bills were, and of course they fluctuated, and we accounted for the spikes. We knew what the utilization requirement was before you start printing money, which is the holy grail a little bit. It's kind of like, any fuel. If you've got the demand, the utilization, go to a gas station, usually a lot of cars lined up. If you've got the demand, you start to make money. The profits are not huge, but the ancillary services, the amenities, and other things that you could sell potentially add to a very profitable business. So around 20 to 25%, and maybe is where you start to break even. It depends on the cost of the capital and how fast you're charging, and how many cars come in that are 900 volts, et cetera, and the policies have shifted favorably to charging by the kilowatt delivered and kilowatt hour accepted. So right around 20 to 25% utilization. If you take a 5-hour day within a 24-hour period, something along that, if you're charging cars for roughly 5 hours, you start to make money. Below that, as part of the 2.0 problem, you couldn't. There are some systems out there today that we put in years ago. They're still only doing 5 and 10% utilization. So you're not breaking even. And the speed at which you're delivering power based on the output of the chargers is not maxed out, where you get a fast turn between each car that comes in. But we are moving very quickly now, where some people say, oh, I don't really need a 400 kilowatt hour charger out there. Well, you don't, because the battery profile is still, you're only going to peak in the middle there for whatever, 5-10 minutes. But you do need to future proof, and you do need to maybe pull a parallel cord on the 400 or the 360. We're leaders in 360 technology. We're going to 600 already, and then 1 meg and beyond. We can talk about that. But as you pull parallel cords, you're still fast charging these vehicles and getting them in and out quickly, where you could start to make money. But that has been a long road before you start to be profitable.
No question, no question. So you talked before about interoperability between systems across like CCS and ACS and others. From your perspective, what actually causes most of your failed charging experiences in the field?
Yeah, so we like to bifurcate that answer because, a failed charge experience. So what's very common is a failed charge experience with a perfectly well-working piece of hardware. And that's often overlooked. And it still happens today. I witness this. I'm still almost a part of it. Like, even when I know everything I need to know, certain software interfaces, it's like, you're kidding me. This is what it looks like. This is pathetic. I'm not naming names, okay? I know them all. It's pathetic. I am an expert in the field. I can't even get my car to charge. The charger works, my car works. So there's a human interface issue. There's I swiped my credit card. Oh, did that credit card work? Oh gosh, gotta go get my other credit card. Did that one work? Oh, is it connected to the cloud? I don't know. Did the credit card failure right at the beginning? The charger works perfectly. So there are still plenty of failed charges, not because of the hardware. And so we have to get a lot better at that as an industry, make it simple. We could learn from the petroleum industry, but interestingly, they still have similar problems as we do. The difference between the petroleum industry, they have service level agreements where if that pump goes down or it fails, boom, they fix it within 24, 48 hours. So you have failed sessions because it's still a disparate sort of different software interests and interface, credit card swipes, some other issues. So lack of syncing. Now, take it to the other side of the bifurcation. You then have hardware and software failures, interconnect and interoperability failures. I'll give you a simple example. This was a crappy story. I was riding with my electric Harley Livewire and electric Energica guys in San Diego. We're heading up to Julian Pie, which is a famous destination for motorcyclists, a gorgeous place and the best pie in the world. And I'm about halfway up and I'm on a system. I plug in, it makes the connection. The handshake is there. We go, we're halfway up. We go get a coffee, come back, failed session miserably. I waited, fail. I can't make it up to Pi now. This is a travesty. I go to unplug my plug and it's locked. I can't even unplug the plug. The software sync not only didn't charge, it timed out, and I couldn't remove the plug. I was effectively held hostage by a piece of hardware. Okay. I'm not naming all the names. Okay. It doesn't matter. This is where the industry was only a year ago in certain types of situations. So a lot of that lead is from lack of full interoperability. So you've got OCPP. Well, your OCPP is a little different than my OCPP. And those handshakes are car dependent. So the car companies would say, hey, charger companies, get your act together. We're showing up. You better be able to charge me. The charger companies are saying, hey, get your act together because you're not going to charge off my charger when you need it the most. So that's an old problem that continually gets worked out and better. There's interoperability centers. The standards are getting a lot better. Firmware releases are getting automated and with remote, downloads, over-the-air updates. And so we're starting to really see a much more beneficial trajectory from the interoperability issues. And yet we still have failed sessions because of human failure, not quite getting it. And we still have failed sessions based on hardware failures. Hardware failures are very common. Display could go out, credit card could fail, the modem could fail and make a connection, although it should still charge. You got a power module, it could drop out. So you charge it slower. It shouldn't turn the system off. but you've got a motherboard issue. You've got a lot of these sort of technical issues relative to the charger. And I'll just make it simple. This is grid equipment with a very high duty cycle in the wild at really hot and humid environments and really cold and treacherous environments. And yet it's computer equipment. It has to act like a normal kiosk or your computer in your office. So it, you know, that's a recipe for disaster. So it's always tough, but we're building and building. We're making it better and better. And the petroleum industry runs through the same thing. The gas pumps, hydraulics, leaks, the same issues with kiosks, displays, and connections. But with the, you know, they've been around for 60, 80 years in their logistical fixes. So they have a very quick fix. And that's exactly where the EV charging market is going, to a much, much higher uptime. And, you know, we're now into the 3.0 where you can even be islanded and resilient, even if your power went down.
Nice, nice.
I recall that from NEVI funding programs. I mean, that was a huge requirement. Like, you need to describe your maintenance plan. You need to describe how, no matter what credit card they have, like, they can charge this, because we're in the Midwest, and west of where we're at, it's very, very rural and very, very far. So it's great, and a huge corridor, I-80 between Boston and San Francisco. Like, great corridor, perfect for NEVI. But it's, if you're going to put this in the middle of nowhere, somebody needs to know that it's going to work, and somebody needs to know that their credit card is going to work, and all of those things. So what you're describing there is huge challenges with experiencing, and it's always sometimes an unfair comparison, because yeah, you look at the petroleum industry and they've had 50 years, 60 years, you know, it just forever, you know, to work through these kinks and bugs and supply chains and all of those. So it's sometimes not a fair comparison. And then the last one is from a profit margin. My understanding is always the fuel from a convenience store is actually a very, very small part of their profit.
Correct.
They're making money on cigarettes and big gulps and lottery tickets. And
I don't buy any of those, but I definitely buy.
You're a bad customer for them. You're perfect for the EV chargers. And but it's, you know what I mean. Just it's the candy. It's, I mean, they are making it off the convenience side of it.
Absolutely.
So to not have that integrated inherently into the EV charging revenue model, it's hard. It would be hard for a standalone gas pump to be effective and make money off of that without the convenience store. So we think of it as the same, but they're not really quite the same yet, as much as we want to try to make them that way.
Well, you know, one of the big things why the Tesla network's usually been a little more reliable is it takes a lot of the stuff we talked about out, because it's just the car, just the charger. You're not using an app. You're not worried about if your credit card's connecting or whatever, you know, and for the most part, it removes most of that. And the huge disparate difference between non-Tesla and Tesla chargers is basically made up by that fact. It's not that their hardware is any more reliable. It's just, you know, it eliminates some of those possibilities of the modem failing, or, you know, some of the other things that goes there.
Certainly, when you take human out of the loop on that, it's much more efficient. Tesla's done a phenomenal job at that. I drive a Tesla. I've been driving one for over 10 years, actually a couple. And they've done such a great job at taking the human out of it. And that is getting better and better and better. And also, they've done a phenomenal job with their plug. I mean, I can remember it was when they first launched the first Model S, and I was at the event. I met Elon at the time, and I believe I was definitely at Schneider Electric at the time. And we spoke about what was required for this new plug. And, you know, we were there with the switch gear and everything, supporting that. It's a great partnership. And I can remember saying, but there's no way you're going to get the amount of amperage and voltage. You were at 400 volts at the time, and the amount of amperage out of a plug this big, it's physically impossible. And I absolutely remember Elon's team unveiling that plug, and it was like a scene from Pulp Fiction when, you know, they open up the briefcase and it's just this bright light and you're not sure what it is. Okay, and they open up this briefcase and there's the plug this big, being able to drive massive amounts of current beyond level 2. That looks like a level 2 plug. So what they've done right is a lot of things. And, we went with CCS, which is still this big. And I consider myself a fairly strong guy. I have to even, kind of wrangle the thing away and kind of plug it in. And I help people who are, let's say, less strong. The little old lady, I've been in Santa Monica where it's like, oh, please let me do that for you. But, she fights the old lady. She's like, I got it. But think about it. You have to think about this. You have to swipe the credit card. You still have to pull out your app. There's a number of apps that's still not consolidated. Tesla's really done a great job because they're vertically integrated. They also have the vehicle. We're learning with plug and charge. I actually plugged my Tesla into a Tesla charger with plug and charge. To a Tellus Power charger with plug and charge. It works flawlessly. So we're getting there. And we still have to work through some of the standardization about where this ultimately goes. But they've done a great job, and it's a great model of success.
Great. Let's switch gears a little bit here. All right, everybody says V2G is coming. What has to be true for it to move beyond pilot projects and become normal infrastructure?
So just come to Tellus Power. That's a plug. Sure, it's a plug. We've got real world money making depots out there using our technology. So today it's real. I'll share a lot of thoughts there. But let's look at the pilots. So for many, many years, look, bidirectional electrons, okay? Back in 2011, I believe it was 2011 or 12, I came public that every vehicle in your workplace will be a fleet vehicle that the workplace will harvest energy at the home, allowing people to charge at home, bring it into the workplace, aggregate that asset, and use it for the building. That the concept's been there for quite some time. Electrons go two ways, folks.
Mhm.
Okay, and being able to harness multi-directional electron flow is really at the cornerstone of what we do from a deep technology standpoint. Now, how does that proliferate? Simple. The first users of V2G are the utilities themselves. Mike, you're aware, you've got a big facility. You're going to test this for your constituents, your C&I, and your home. You might as well try it at home first with your own fleet vehicles. So V2G has been working in the pilot form for many, many years in that sort of controlled environment because they can control everything. Also, large manufacturing facilities, vehicle OEM manufacturers have V2G, V2X working as pilots within their own controlled environments. They need to know, how does this work? And can we warranty the batteries? Is this a value added for us long term? Should we be using this for passenger vehicles? Should we be using this as we create class 4, class 5, last mile delivery vehicles? The market is wide open. So that's the pilots. As you move toward real money making capability, I'll give you an example. One of our key customers and partners, ultimately, they required Oakland Unified School District. This is the best story. It's real. We'll share the data. You've got a relatively disadvantaged neighborhood. They're having a tough time with the price of diesel. They've got to pick up the kids. They've got a pretty known duty cycle on when to pick up and drop off the students. Very expensive diesel, operating in the red. Older building, some losses, not a sustainable building. This is where grant money really helps. So grant money goes to the municipality, and there is now a hardware provider such as us, a software provider, which is our partner, a fleet operator, which is another partner, a bus system company, a vehicle, an EV vehicle that's willing to do this. You've got software that's managing this, a solar canopy, and a grid operator and utility. So that does what it is what it takes. But now, check this out. They're now their fiscal budget has been flipped because all the money they were tossing down in diesel, they can never get ahead. They flip that where they're producing their own energy. They are dispatching energy back to the building that is aggregated from these batteries at night and during the duty cycle. There's no disruption in picking up the kids. They've completely flipped the economics around to now they can afford better salaried teachers. The teachers come in, revitalized neighborhood. This is a complete change in how they used to operate. That's real, and we're seeing a little foreshadowing here. This can be replicated 1,000 times and is already starting to be replicated 100 times. And that's the deep tech that we deliver.
It's amazing. I think I may have seen a presentation on that at Distributech a couple of years.
Yes,
it was just phenomenal. It was win, 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 win. You know, just how is this a bad thing from anyone's perspective of what this looks like?
It can be replicated. It's being replicated within the same group of partnerships I just mentioned, and also replicated with different partnerships. So we're going to start to see this expand rapidly. And really, we would also say that there's been some attrition in the V2G story, because why would anyone deliver this V2G hardware if it, like you say, David, it's always been talked about, but never really scaled? That's fair. Right. So the companies, there's a lot of false attempts, but Tellus Power, we've been in it since in the early days. We have staying power in it, and we really rely on our partners. It would be unfair to say it's purely about the deep tech, but certainly we have excellent deep technology to be able to do this. It's not just about electrons going one way and another. You've got to, because once they go that way, you have to make sure that they're safe upstream for the grid. You have to monitor the use within a stationary battery storage. So it does get a lot more complex, and we've been doing a real good job there. But we expect this to be a very strong market moving forward.
You know, it's funny. We've done some discussions about various electrical school buses that have come to market, and where some school districts have had some pretty big adoption. And just I've gotten on some of those videos, and when we talked in the video about how just, do you really want your kid to be sucking in diesel fumes on the way to school?
It's horrible.
Like, I was a child at one time. I don't remember any diesel fumes, and it's like, well, maybe that's because you ingested all the diesel fumes. You know, it's like you really don't remember that smell. You know,
look, I always like the smell of gas. So I'm a public guy that says, yeah, I actually like the smell of gas. It's not good for you. And the diesel is absolutely the worst. The particulate matter of diesel, the size of the molecules, and it's absolutely a carcinogen. It's been known to cause a much higher asthma rate, especially in disadvantaged communities where happens to be some congestion. We've done a lot of studies in my prior company around ports. The Port of Long Beach, Port of LA, the amount of drayage machinery driving around, the amount of hauling. And this is a real sad reality. 35% of all employees that have this great job security of working at the ports for their families live within a 5-mile radius, because that's the beauty. You get to go 5 miles to work and back. Hard-earned living, built, for your family. You've got job security in a effectively inexhaustible delivery of the 2 largest ports. Their level of premature deaths and asthma rates are through the roof. This is a travesty. So, at the school district, it's not quite as of a bigger problem, but it is definitely a problem. And, now we're absolutely solving that problem. We're solving the health-related issues, which, we have to be concerned with. We're solving the economic-related issues. Can you make money? Can you save money? And we're solving the efficiency. And we get these quiet school buses bringing these young children in and out. It's a phenomenal story. It will be replicated extensively.
Without a doubt. Yeah, it's amazing to see. And that's, of all the different use cases for V2G, the big batteries on the school buses make a lot of sense. I mean, what would you have got? 300 kilowatt hour probably? I mean,
yeah,
pretty sizable amount.
2 and 300. And then you've got last mile delivery, You've got transit bus. These are target-rich environment for higher than class 2 and class 3 EVs.
Yeah, it's phenomenal, and that's what I tell people. I get asked that too, like when is this big V2G and the marketplace and all of this, and why? It's the reason why is because people haven't done it. Like the technology's there, the demand is there, the use case, the economics pencil out, and it's not this, Julia Child's art of French cooking complicated recipe where you have to pull. No, you're making a burger and fries. You just get the right people in the room. It's just you have to have the right partnerships. You have to understand what you're doing, and like it's not hard to repeat. I mean, you can do this over and over again. It fully exists. It fully exists out there.
We're scaling into the thousands of V2G charger now, and we never did. And I guess I'm proud to say I am one of those short order cooks now. So I'll be flipping those burgers.
I love it.
All right. So you've argued that EV infrastructure can't be treated as passive load anymore. What does a charging company need to become if it's really going to be part of the grid?
Yeah, that's a great example of what was, unidirectional charging one way, very important period. And, charging 1.0, 2.0, and even 3.0, you still need a strong base of unidirectional charging. But when you then look at the difference between that passive load, those days are kind of numbered. It is really becoming an active load, right? So it's not a one-way charge. And I also want to say this goes beyond V to G. It's what we call energy transfer. It's effectively multi-directional electron flow. What does that mean? Multi-directional electron flow. Yeah. Bottom line, you have a charger. You have a vehicle that's going to pull that power. You have an asset in that vehicle that is effectively a roaming stationary storage device. You have a stationary storage device. You have an active generator of power, whether, what it might be in a microgrid at the edge. You have utility power that may be still coming from centralized transmission and distribution. So when you look at the moving forward, there's really no longer passive load that we just say a load's going to go up because e-mobility is going to increase, which it is, and it will continue, especially globally. But now it's what do you do with that electron? It's not a one-way source. The more you can transfer the energy throughout where it needs to sit at the right times is that is really the holy grail. That makes the grid more resilient. It makes the grid more stable. Every time you have a dispatchable asset within a situation, call it a microgrid or distributed energy resource, you now are managing a massive uptick of being able to be capable of managing what was once this passive load. So it's really flipped in 3.0. Moving forward, it's flipped from just being a passive load to being a very active load and being able to monetize or even tokenize the energy, multi-directional energy within this microgrid. And if you're able to do that, which we're able to do, and you start to replicate that either in a C&I environment or a home environment, you're creating a virtual power plant.
Oh, go ahead, David.
Well, I was just going to say, one thing that's really stuck with me over the years that I've done this show with Mike Herzog is I remember Mike saying one time is our grid was originally designed to only work in one direction. And now we're forcing it to go in two ways. The grid's existed for over 100 years, and it was only designed to send power from the power plant to your house. And now we're sending it in all kinds of directions.
Yeah, 100%. 100%. It's crazy to see that evolution and moving in that space and what we see. And really, like, electricity is the only commodity that previous to now had no storage. Everything was instantaneous. It's you need an electron right now. I will produce you an electron right now. We have gas storage tanks. We have water storage tanks. We have grain silos. We have warehouse. Every other commodity there's storage, but electricity has been the only one. So from the grid perspective, all of a sudden that opening up, it's a whole new world. Like we can move. Like I love your description of it, Mike. It's we're moving the electrons around physically. Like we can transport them to these different locations and store them for use when it's most optimal.
All right. So Mike, you explicitly tied AI-driven edge demand to Tellus's roadmap. So how is this changing the way you think about edge power, large loads, and distributed energy?
Yes. So if we all take a look at what everybody knows now about AI, it's generative AI, cognitive AI, large language model exists in the cloud, and a massive race to build superscalar data centers to be able to crunch and become a much more intelligent society, including extend humanity and extend human consciousness. It's been a mission of mine back in the very early days that this is a grand challenge, that we need to extend humanity and extend human consciousness. There's some other people in the world that feel similarly. In that race now, what are we going to do? Because I've been in the supercomputer industry for many, many years, and we were building football size, not building personally, but delivering chips for football size data centers and supercomputers. Why? To model the climate, as we're incrementally heating up the climate to run these massive supercomputers. So what you have now is this massive race for data centers. So how do you solve that problem? Well, go where the power is. So you see, Facebook is cutting large licensing contracts with solar and wind farms. You've got Microsoft and Google putting data centers near nuclear power plants. You've got this massive peaker plants where people are bringing data centers to hydro plants where the generation is. So that's a massive baseload, gigawatt baseload. That's a 5 nines reliability requirement. And even Elon saying, oh, we're never going to be able to do it because we don't have enough water and resources locally, on Earth. Let's put these in space. And now Amazon is now also looking at that. We'll put them in space. You've got an inexhaustible power source from the sun. You have very high efficiency in solar panels. You have infinite cooling. There's no cooling requirements, which are the big problems here on Earth. And then you need the water, and it's a natural resource. So it makes a ton of sense. Are we there yet? We're getting close. But that's a big problem in its own. Now, where does that leave EVs? Where does that leave autonomous vehicles? Where does that leave logistics, automated logistics and delivery? Where does that leave humanoid robotics in factories? That's the difference between cognitive AI at a centralized command and control, centralized energy source to at the edge, where we're calling this physical AI. And it's not part of the dialogue yet. It is now. We're speaking of this heavily because physical AI, a RoboCab, a Waymo, a Zoox, is a robot on wheels. It's no different. And then humanoid robotics are robots that look like humans that walk. Then you've got warehousing, you've got drayage. There's this massive load required at the edge where people thrive, they work, they breathe, they eat, they sleep. Now you're seeing this exponential growth with some regulations being more favorable today. Tesla's RoboCab, Waymo, city to city to city to city to city. How do you charge them? So is there enough power on the grid? That's what I just described as being at the edge. That's why it is critical. And there is a tremendous growth trajectory for Tellus Power, being able to power physical AI at the edge, just like we are power limited. You talk to these superscalar guys, they answer their capacity in watts. I'm like, where's the flops? Where's the MIPS? No. We're never compute limited. We're not memory and compute limited or bandwidth limited. We've never been. Moore's law continues. We're always power limited. That's why we're shooting things up in space, because of unlimited power. So when you look at where people live and breathe, that's what Tellus Power is changing. We're effectively powering physical AI at the edge through, what does this company look like? It starts to look like a DC fast charger company with bidirectional, multi-directional control, with energy storage fixed to the DC and stationary. That's actually the deep technology. You got to be able to do that right. I'm a big believer. I'm a hardware guy. SaaS and all this is getting disrupted by AI. Hardware is not getting disrupted, not yet. In the future, it will. Humanoid robotics will build humanoid robotics in space, expectedly in the moon. That's very future, but that will come about. So right now we need these solutions at the edge where we are, where we breathe and eat and sleep, and that's the exponential growth trajectory of these new autonomous vehicles and robots, and you need to power them. So all of our discussion is physical AI, and that's what Tellus Power delivers.
Nice, nice. We've talked a lot on here about how if you're going to get to the point of having like megawatt charging, you're going to have massive battery storage there, because you're not going to be able to dispense the power straight from the grid at megawatt speed into the charger. You're going to have battery storage there that can rapidly dispense that megawatt into the vehicle and then slow charge the battery back from
when it's cheap.
Right. And, that's such a big piece of it. And that's what, we've seen a couple of the Chinese companies doing already, is how they're being able to massive it. And one of the things Mike was talking about, when you're charging at a megawatt, you're only charging for like 4 or 5 minutes. And so that, you're not having to have tremendous constant usage. And so it's not every single vehicle in the world charging at the same time, in that kind of situation. All right, I got a funny one for you. What part of the EV charging business looks easier in a PowerPoint than it does in real life?
By the way, David, I looked at your questions before I even formulated answers. I said, okay, this guy's got the best questions of anybody, because they're very provocative, and I really appreciate it. And that one hits home, because we have the master ultimate slide, to be a little self-deprecating here, of this entire charging depot with 70 vehicles and the grid. And, the grid always looks like some T-line. It's the grid. It's a great PowerPoint slide, right? And then there's a box. It's the stationary storage. And there's a whole bunch of buses. And, it's so easy. And there's the little charging devices that we do. And it's so eloquent and it's perfect. And, we get rid of the power conversion unit, because everything's DC to DC in this energy transfer. So you don't have to invert, and, you go from AC to DC and DC to AC back and forth. So you have this highly efficient microgrid solution that is so simple in its architecture. And that's that killer slide that we deliver. Now, that's not so easy to get done, because each one of those plays a valuable role. The solar, the fleet operator, the technology deep tech deliverer, the municipality, the bus company, the utility, the community. It gets quite. But it is it's still, we don't remove that slide. It is effectively what we do. But certainly, when I put that up, it's quite impressive of how simple it all looks. And, in the future, it is getting more simple and more simple as you're seeing battery costs come down and become below 100 kilowatt, $100 per kilowatt hour. 10 years, 12 years ago, 15 years ago, it was 1,200 to 1,500 per kilowatt hour. You're down a step change, 10x step change. Now the magic begins. It truly does make sense. We're at the point we can make a competitive EV at the same exact price as a competitive ICE with the same range, very fast charging, because of the cost of batteries as those go down. So now you're seeing that is absolutely working to our favor. Globally and even in the US, the president administration certainly favorable to energy and battery and so forth. So we see that's the hard part, but we have the best slide in the world. And, at the end of the day, it's a whole bunch of people trying real hard to make that concept a reality.
All right. So what's one commonly repeated belief in EV charging that you think's wrong?
Yeah, I think we touched upon, there's a few, but we definitely touched upon it that, oh gosh, what do we hear? BS thing. And if we instantaneously switched all the gas vehicles to EV, the world would collapse. That's a bullshit question. Okay.
Yeah.
All right. That's a horrible path. So let's be realistic. And you can bleep me on that. I don't know. But anyway, let's be realistic. This is a consistent turnover of new technology versus old. It started as early as the 90s, but let's call it realistically, 15 years ago. And, let's say 2010, when the first two production vehicles came out, the Leaf and the Volt, if you want to go back to then, and Tesla's, Roadster. So fast forward 15, 16 years later, we're in a situation where these things are starting to work. They're working well. They take time. They're creating a forcing function for an intelligent grid. We see this natural adoption of EV because people love these vehicles, not because they're greenies. I mean, there's plenty of climate change activists, but these are great for family vehicles. You don't need a gas-powered vehicle and an EV. I always like to say commuting is a horrible application for gas. We definitely need petroleum, period. Jet fuel, long-haul shipping, long-haul trucking, aviation, maritime, even today in various applications. But to commute to work and back, or just to drive and get your groceries, it's not a good application. We will start to see a changeover regardless of administration, because people love these vehicles. And once you go EV, some people do go back. I always thought they never would go back. Some people do, but most people stay with an EV and they just go more and more. So I believe it is, the future is very bright for EV. There's no turning back. Look at what China's doing. This is a blip on the screen for the US. I've been through two Obama. I'm dating myself, but I'm still young. Two Obama, one Trump, one Biden, another Trump, 5 administrations. Nothing's changed, folks. I do remember never wanting to give up my Nokia 1000. Love that. I texted all the time on that. I went to a BlackBerry. Over my dead body would I go to an Apple? Why do I need to watch TV on my phone? I'll never give up my tactile response. Right now, I exclusively use Apple. It's a plug, which is a supercomputer in my hand. And I still have to deal with that kind of quirks about the keypad. Bottom line is EVs, absolutely a better driving experience. I'm not talking about people who race Ferraris and Lambos and all that kind of thing. We will never get rid of that. Don't ever get rid of Formula One gas. It's phenomenal, okay, that experience. But when you're driving, let's be realistic. Humans, we do two things at our core. Well, we procreate to keep the species going, but effectively, we walk and we talk. We communicate and we travel. I'm one that would rather communicate and have someone deliver me to my destination, especially in San Francisco or LA, where high density populations are, or in New York, than I would otherwise. And that is absolutely a human drive to move forward with EV adoption and move forward with autonomous vehicle adoption. And yes, I'll go to the races all the time and watch it. We still race horses. Okay. But as far as in general, overall, absolutely, EV is the way the world is moving because of all the capability and the technology.
All right. Well, Mike, I want to thank you for coming on our show today. You've been a real delight.
Great.
I want to thank everybody for watching. And I'm going to go ahead and end the stream.